After a reaction, you might need to separate your desired product from byproducts or any leftover starting material. A quick way to separate these things is liquid-liquid extraction. Let's look at an example. A separatory funnel, or SEP funnel, is placed into a ring clamp, and a beaker is set below it. The stopcock is moved to the closed position. An aqueous solution of sodium hydroxide is then poured into the funnel. Make sure to check the stopcock for any leaks that might occur. A mixture of organic compounds is dissolved in diethyl ether and then poured into the funnel. This mixture contains two dissolved solids, benzoic acid and benzyl. Notice how the water and the ether do not mix and form two separate layers. This means they are immiscible. This is a requirement for liquid-liquid extraction. Each of these layers constitute a phase. The aqueous phase is the water-containing phase. Since it's more dense than most organic solvents, it's usually the bottom phase. The ether is called the organic phase, and it is always the top phase since diethyl ether is less dense than water. There are plenty of other organic solvents that can be used for extractions. Some of these might even be the bottom phase if they are more dense than water. For now, the benzyl and the benzoic acid are dissolved in the ether. The goal of the extraction that I'm going to perform is to selectively move one of these compounds from the organic layer to the aqueous layer. Sometimes this can be done by differences in solubility alone, but in this case, we're exploiting the fact that benzoic acid can react with sodium hydroxide and form a compound that is more soluble in the aqueous phase than in the organic phase. To accomplish this, the layers must be shaken together. The SEP funnel is stoppered and then picked up. Notice how the palm places constant pressure on the stopper, so when it's inverted, the stopper is not removed. The other hand, which is my left hand, is used to keep the stopcock in place. For the stopper, I use my right hand to hold it in place because I am right-handed, but you should use whatever is the most comfortable for you. After inverting the funnel, the stopcock is briefly opened to release any pressure that builds up. Once the stopcock is closed, the SEP funnel is vigorously shaken. Just make sure you aim the direction of the SEP funnel into the back of the fume hood to avoid any potential accidents. The funnel should be vented every few shakes to avoid excessive buildup of pressure. The funnel is then placed back onto the ring clamp and the two layers are allowed to separate. You should then remove the stopper. If you leave the stopper in place, none of the liquid will be able to leave the SEP funnel. At this point, most of the benzoic acid has converted into the benzoate ion and moved into the aqueous phase. The stopcock is used to drain the more dense aqueous phase into a pre-labeled beaker. The last few drops at the interface may be retained or flushed out. This depends on which layer you intend to keep more pure. To ensure that every last molecule of benzoic acid is separated, more sodium hydroxide is added to the funnel and the process is repeated again. Additional portions of the bottom layer are combined with previous portions. The top layer should be poured out of the top of the funnel into a separate pre-labeled Erlenmeyer flask. The separation is now mostly complete, although there are still trace solvents present in each layer. Magnesium sulfate is now added to the organic layer. This solid forms a complex with water. This will sequester any lingering water that's present in the organic phase. The organic layer is then filtered. The solvent will be removed under reduced pressure generated by a rotovap. The benzoate ion, which is found in the aqueous layer, is then converted back to benzoic acid using a strong acid. The benzoic acid is not very soluble in water, and therefore starts crashing out of solution as a white solid. This white solid can be collected by filtration and then dried. Extractions can use different organic solvents or aqueous solutions of various pH, but the steps remain the same. If you know the solubility and the reactivity of your target compound, extractions become a powerful separation tool.